All right, hi everyone. Today I'm gonna do educational code forces around 101, and it started. So okay, we're in problem A. Let's see what this is about. So we're given a regular bracket sequence. Okay, so these are common. Maybe it should have been named another regular bracket sequence problem because okay. Anyway, so you are given a sequence of okay. Mm, okay, so one character. Mm, Okay, one opening and one closing brackets are there, and everything else is a question mark. So, okay, we need a regular bracket sequence after replacing the question marks with brackets. Okay, and we just have to answer yes or no. Okay, so I think if the length of the string is odd, then obviously it's a no. Other than that, if the first one is a closing bracket or if the last one is an opening bracket, then it's no. Otherwise, in all cases, it can be a yes. Yeah, okay. Otherwise, in all cases, it's yes. So these are the two cases when it can be no. So we have test cases and okay. Now, if size s is um, okay, if size is if it is odd, okay, or if the first character is equal to a closing bracket or if the last character is equal to a opening bracket an opening bracket, then the answer is no. Okay, otherwise the answer is yes. Okay, so that was pretty straightforward, I think. Okay, so it's correct. So let's submit it. So how to prove that in all other cases it is possible to get. Okay, so we got accepted. So how can we prove in all possible cases we can actually get a bracket sequence that is correct, I mean regular. So to show that we can show that whenever we have a whenever we have a closing bracket we just need uh, whenever we have an opening bracket we need a closing bracket on the right of it. So if there's at least one question mark on the right of it, then we can balance it if it's even. If it's odd, then it is impossible. Okay, so we're at problem B now. This is red and blue. The monocarb had a sequence of n plus m integers and he painted the elements into two colors. Okay, red and blue. I think, okay, yeah, n are red and m are blue. Okay. Mm, okay, so R is the sequence of red colored elements and B is the sequence of blue colored elements. Okay, in the order they appear in A. Okay, fine. The original sequence was lost. Okay, and monocarp only has the sequences R and B. Okay, I think we have to merge them to make a sequence A. And he wants to restore the original sequence. In case there are multiple ways to restore it, he wants to choose a way that maximizes the value of this thing. Okay, so we want to maximize the value of this, right? So since there is a zero here, uh, this value will either be negative or so this value will either be negative or it will be zero. Okay. So can we do a binary search or something? Mm, let's see. Wait a minute. We just have to calculate the maximum possible value. So can we do like the answer will always be, oh sorry, this is max. Okay, okay, sorry. So the answer is either 0 or something positive. I thought it was min. Okay, so it's max. So can we do a binary search? No, I don't think it's a binary search. Okay, so for the maximum, right? I think we need to get as many positive elements as we can, but then we can have a few negative elements, and again we can have positive elements. So that's not how it will work. Okay, since n is small, I think we can choose two indices. We can choose a I in this sequence and a j in this sequence, and then we want the maximum value of the prefixes of length I in this plus the prefix of length j in this. I think that's what we have to do here. Okay, so first I'll code this. After that, if it works, I'll explain how it works and what it was. Okay, so okay. Hmm, okay. Then we have M. Okay. Okay. Now we just have to brute force it, right? 100 into 100 into okay, yeah, we can do it. Okay. So right, and we print the answer. Okay. So answer could be answer or Ri plus Bj. Okay. I think that's it. Should work. Okay, it didn't work. Okay. Okay, sorry. This is M. Okay, it worked. So let's see if it works, and if it works, then I'll explain what I did. Okay, so it got accepted. Now let me explain what I did quickly. So we had two sequences. There was a red sequence, and then there was a blue sequence. Okay, and what we had to do is we had to merge them, like merge the elements in a way like we can pick. Like we can pick the first element from this, then the second from this, then a few elements from this, then from this, and so on. Okay, so we don't change the relative order of elements within a given sequence. Okay, so then we wanted the maximum prefix sum of this new sequence that we create. Okay, so any prefix of this will be the sum of a prefix of this and a prefix of this. Okay, because like if we have taken the values up till this point from this sequence, all of them are somewhere here, and all of these are somewhere here, then this element will be the sum of all of these value, right? These values. Okay, so we just needed to maximize the sum of these two, right? So for that we can actually store the prefix sum of this sequence. So essentially this means that at this index I'll store the sum of all of these elements, and similarly at this index I'll store the sum of all of these elements. Okay? So yeah, that's what I was doing. Then for the answer, I'll just pick one element from this and one element from this, and I want to maximize the sum of these two, and that will be the answer. Okay. So to do this, I can try everything because there are only 100 elements here and 100 elements here. So this is 10 to power 4 per test case, and there are only 10 to power 3 test cases. That's why we can do it using brute force. So yeah, so that was this question. Now I think we can move towards problem C. Okay. So it's about building a fence, right? So we want to build a fence that will consist of n equal sections. All sections have a width equal to 1. Okay. And height equal to k. You will place all sections in one line side by side. Unfortunately, the ground beneath the fence is not flat. So okay, the ground beneath the fence is not flat. For simplicity, you can think that the ground level under the ith section is equal to hi. Okay, so the ground is not flat to begin with. Then we have to follow several rules to build the fence. The consecutive sections should have a common side of length at least 1. The first and the last sections should stand on the corresponding ground levels. Okay. The section between may either be on the ground level or higher, but not higher than k minus 1 from the ground level h. Okay, and the height should be an integer. Okay. Is it possible? Hmm. Okay, we need at least something in common. So yeah, let's see what we can do here. Okay, so h and k are a lot. Hmm. Yeah, h and k are a lot. So what do we do? Hmm. Okay, so think I think for each position we have to store the range in which it can cover. We have 2 points, I think. This top and the bottom point. So are the heights fixed? Okay. Hmm. Okay, so all have height equal to k. All of these fence block. What are these? All of these sections have a height equal to k, and these could be variable. Okay, so hmm, so yeah, I have kind of two bounds maybe. One is like the highest point at which this can be placed, and one is the lowest point. And then corresponding to this, I can get maybe the highest and lowest for this as well. I mean, it will depend on this. So like it cannot be smaller than the lowest of this, and then cannot be greater than the highest of this one minus one, I think. So yeah, I think that's all we have to do here. Mm, yeah, I think that's it. So it's something like okay, so we kind of have these fences. Okay, so we have these fences, right? And what we will do is we will just store this point and this point, like the minimum value of this height and the maximum value of this height. So basically, like for the next fence, the minimum will be at this point, but we can go as high as we want, right? So the maximum will be at this point. So corresponding to this, the let's say we have a blockage here. Okay, so like the ground is not even, and this part is blocked. Then the next fence could start here. Okay, so this will be the minimum, and for the maximum it cannot go above this because then nothing will be common. So we just need a minimum and a maximum, and after that for the last fence, if it satisfies for the last fence, because the position of the last fence is fixed, right? Like the first and last should be on the ground levels. Okay, so if it satisfies for the last fence, then the answer is yes, otherwise it is no. So that's all that we have to do here. Okay, so int n and k. Okay, then need the heights, n heights. Okay, so we have the n heights now. Okay, that's all the information that we need for a test case. Now we have to just solve it, right? So we need the minimum and a maximum, right? So I think the minimum is this. Uh, let me store it as h. Okay, so the minimum is definitely h0, and the maximum is h0 plus h0 plus k, I think. Mm, this height is k, so if this point is h0, this is h0 plus k. But I think we care about this point, right? Mm, h0 plus k minus 1 or h0 plus k. Yeah, h0 plus k is fine. Okay, so these are the minimum and maximums. Now we start from 1 up till n minus 1. Okay, because I'll process the last one separately because it has a special condition to it. That's why I process the first one separately. Okay, so now like I have the height hi here. Okay, so by default it can go from hi till hi plus 2k minus 1, because the height is k, and it can go k minus 1 further than its actual height. Okay, so this okay, so the minimum will be the minimum of the actual minimum and hi. Okay, so this will be the minimum, and the maximum will be okay, sorry, it will be the maximum of the previous minimum and the current height, and the maximum will be the minimum of the current maximum and this value hi plus 2k minus 1. Okay, I think that's it. So this minimum maximum, okay, this range minimum to maximum, this should have some intersection with the last block. Okay, so the last block is from h0 till sorry hn minus 1 till hn minus 1 plus k. Okay, so it should have some overlap with this, right? Okay, if if the maximum is smaller than hn minus 1 plus k, okay, and the minimum is wait a minute, sorry, I think the minimum should be smaller than this, right? And the maximum is greater than I think we can just merge this one too. So mn comma hn minus 1 and mx comma hn minus 1 plus k. Okay, now we just have a simple condition. So this min is should be smaller than max. If this is holding, then it's yes, otherwise it's no. I'm a little confused right now as to maybe this condition, maybe it should be smaller equal to, not sure. Okay, but let's try to run it on the sample. Okay, so maybe it is actually smaller equal to. Okay, we still have the wrong answer, so I think I did something wrong. For the first one we're getting no, right? I think it's best to just print the values. Yes, min became greater than the max. Okay, I think I did something wrong. Yeah, I did. So, okay. Yeah, something is wrong here. I think this part is correct, but this part is not correct. Because the max can be definitely greater than this, right? Just that we add a k later. This is wrong. Max should be minimum of mx minus wait, one value is definitely h plus 2k minus 1, right? But what is the other value? If we start just below the max, right? So if we start at mx minus 1 and go all the way till its height till k, I think this should be our new max. Okay. and this is also wrong. It should actually be the minimum is the maximum of the point at which this starts. Okay, and the other thing can be if we start just above the minimum. Okay, so we start at mn plus 1, but we subtract its height from that. So it still looks wrong. Mm, sorry, this is hi. Okay, yeah, okay, these values look more correct now, but we did something wrong here. Okay, I think we should remove this and have a proper condition here. Okay, now for the last one, mm, okay, so we have to place it in a way that there's some overlap, right? So this minimum, okay, this should be smaller than the upper, and the maximum should be greater than this b. Okay, I think now it's correct. Okay, it's still wrong, I think. And I think it did run on the sample, but I'm not sure if it will be right. Actually, the implementation is a bit tricky here, and that's why I'm messing it up. I wouldn't be surprised if it gets a wrong answer, but it got accepted. So I'm a little surprised, but yeah, I'll explain what that was. I got a bit stuck in the implementation, but the main idea is that like the first block is somewhere here. We have a minimum and a maximum, right? Then according to this, we can have the second block slide up and down. So we'll have a window, like this block can be from here to here. So we'll have the new maximum and minimum according to that. And we just have to keep moving from left to right, and we just have to check that these blocks can overlap with this window. So yeah, we just had to implement this, which was a bit tricky for me. So anyway, on to problem D now. So we have an array where a okay, so this is a permutation of length n. In one step, we can choose two indices. Okay, so we can choose a y and divide y from x. This is the ceiling function, okay. So we want to make n minus 1 once and 1 2, okay. And no more than n plus 5 steps. We have to print the steps, right? Okay. I think if we didn't have to create this 1 2, I think then it would have been very easy. Like it's something like we have this sequence, okay. So we could have done something like just divide this 8 from everything, and we get this sequence. Okay, so this was easy, but we don't want this, we want this. Okay. And yeah, the order then doesn't matter, so we can have this anywhere. So we want a 2 as well, not just the okay. Maybe it's still not that hard, I think. Let's see. So what we can do is we can definitely get this sequence, right? Just divide this 8 from everything, and we will get this. After that, if we divide this 7 from this 8, then we'll have this. Sorry. Okay. Then we'll have this. Okay. But then we can't convert this 7 into a 1, right? That's a problem. That will take a lot of moves. Right. We have n plus 5 steps, right? Okay. Okay. So yeah, this won't work. What else can we do? Can we use this 4? But no, I don't think that will work because uh, we'll have to, that will cost us login moves or something like that. Because it's easy to make a lot of ones, but the problem is um, like how to get rid of the greatest element, right? That's the problem. How do we get rid of the greatest element? So n plus 5 seems like a very tight bound. Let's see how they did it for 4. I think for 4 it's much easier mm, than other numbers because 4 is a small number, right? Maybe we can just use our mm, what did we do? Okay. Mm, mm, did 3 moves. The first move was 3 4. Okay. Okay, then he did 2 more moves like this. Okay, yeah. So for 4 it was easy, but we can't use the same thing for other numbers. So what should we do for bigger numbers? So one thing is sure, we already have a 1 and there's no way we'll touch it. So technically we have n minus 1 elements and n plus 5 moves. Okay, because we won't touch this. So 6 extra moves apart from 1 move per element. Okay. Now maybe we won't change the 2 either. Not very sure, but this seems kind of obvious, but it might be wrong. But probably we won't change this 2 either. So these 2 will never change, and we just have to convert all of these into ones. Okay. Hmm. I can't think how to do this for any bigger n. How do we convert this 8 into a 1 or a 2 for that matter? We can use this 4 for that, and this 4 can make it a 2, and before that we could have converted all of these into ones. Okay, that's fine, but Then how do we convert this 4 into a 1? Mm, yeah, that's tough. Mm, okay. Okay, so yeah, maybe we have to use the food. Hmm. We seem to have at least 5, 6 extra moves, right? So how much is? I think we have 6 extra moves. How much is 4 to power 6? Not much. For this value, I think we need 2 to power 18, right? How much is 2 to power 18? Yeah, 2 to power 17 or 18, something like that we want. So if we are gonna use force, we need at least hmm, 8 extra moves or something. I think we do have 8 extra moves. If we leave these two, okay, and we leave the last element, okay, so if we leave these 3 elements, then we have n minus 3 elements and n plus 5 moves. So we have 8 extra, right? Yeah, we have 8 extra. I think we need 9. Maybe we can use the 5, okay? So let's see, 5 to power 8 is like, that's a lot. Hmm, definitely bigger than this. How much is 5 to power 7? It's not. So if we use 5, we can do it. But then we will have to remove the 5 as well. That will cost some extra moves. So if we use the 8 to get the last element to 1, we can do it in 6 moves. Okay, let's try it this way. So we have a lot of elements. Maybe we can use the 7 also. Hmm. Okay, 7 or 8 or something. Okay, so let's see. So we have this 8, right? And then we have a lot of other elements. So I think we can use this n to convert all of these into ones. Okay. Now we have to change this n into a 1. So for that we can use this 8. Okay. And then this can be done in like 8 to power 6 is greater than 2 into 10 to the power 5. So we can do it in 6 moves, I think. Let's see. So if we have the biggest element, okay, one move, two moves, three moves, four moves, five, and I think, yeah, I think we can do it in six moves. Three moves, and we start from 391. Four moves, five moves, and six moves. Okay, yeah, we can do it in six moves. So this becomes a one, and how many moves did we use? So we used n minus 8. No, wait a minute. These are n minus 9 elements. Okay, so we used n minus 9 plus 6. So we used n minus 3 moves. Now we have 8 more moves. So can we do this in 8 more moves? So if we can do this in 8 moves, then we have a solution. Okay, so in 3 moves we can do this. Okay, now we have this and 5 more moves. And then I think we should use this 4 here. If we do that, we will have okay, and 4 more moves. I think we will be able to do it. Then we will use this 3 here. No, wait, this 2 will do the same thing. So we will just use this 4 to remove this 3. Okay, so we get 1, 2, 1, 4, 1, 1, 2. And now we have 3 more moves. Okay. Yeah, so we can use this 2 and 2 moves here and 1 move here. So finally we'll have 1, 2, 1, 1, 1, 1. And everything else was already 1. So yeah, we got a solution. So that's what we have to do. Okay. I think this was a nice ad hoc problem. I'm glad I found the solution. But so we need to wait. We need to preserve our 1 because we don't have to change it. Then we have to save the 2 because we won't change it either. And we need the 4 and 8. So we need to save the 1, 2, 4, 8. Apart from this, everything else we have to convert into a 1. Okay. So if n is smaller than 9, I guess, then we should solve it separately. Okay, I'll do something about it. But apart from that, what we can do is, okay, so just store the moves. Okay. Um, I saved 1248. Apart from that, everything else I'll convert it into 1. So I think x comma y, right? Okay. So I need I comma n. After that, I need to convert the last element into a 1. So we can do the 6 moves. Okay. So this will convert the last element into 1. Okay, so let's keep a track. So till here, I think we've done um, n minus 1 minus 4 equal to, so till here we've done n minus 5 moves. Now we've done 6 more moves. So now we've done n plus 1 moves. Okay, I think we have 4 more moves now, and all that's left in the array are 1, 2, 4, and 8. Okay, a multi-set of this, and I think 1 doesn't matter because like we have to convert everything into 1. Okay, so we have 4 moves now. So what we can do is we can just use this 4 to convert this 8 into 2. Okay, so move dot pushback. I'll use the 4 to I'll use the 4 to convert the 8 into a 2, and then I think I'll do it again to make it a 1. Okay, so now we have done n plus 3 moves, and we're left with a 2 and a 4. Okay, so now do 2 more moves, convert the 4 into a 1. Okay, so now the 4 is a 1, and yeah, now we have just 1, 1, 1, 1, 2, and we've done n plus 5 moves. We didn't have to use the vector because we have exactly n plus 5 moves. But anyway, so we can just assert it as well. Assert size of moves equal to n plus 5. Okay, now just print n plus 5 because we're using exactly n plus 5 moves every time. Or in moves, let's just print all the moves. Okay. Okay, so that's it. Yeah, so this is it for the general case, but we have some corner cases when n is smaller than 9. So yeah, there are some things that we can't do now because n is smaller than 9. So we need another solution for this. Okay, so I think we'll do the same thing. We'll conserve till one, like we'll save 2 and 4, right? Then we'll try to delete everything else. Okay, I think we need another case if it is smaller than 4. Okay, now if n is smaller equal to 4. Okay, so for this we can just print it. Mm, wait, okay, so if n is equal to 3, okay, let's just print this thing. 2 backslash n 32 backslash n 32. Okay, yeah, that's fine. Now if n equals 4, let's print this. So this is 3 backslash n 34 backslash n 42 backslash n 42. Because like the corner cases are so specific, I um I think this is better than actually coming up with the logic. Okay, so now if this is smaller than 9, then at least it is greater than 4. Okay, so we already know that n is greater than 4. So I think we again need the moves. Okay, so we'll use the last element to convert everything into a 1 except the 4, except the 2 and 4. Okay, so I think first of all let's convert the 3 into a 1. Okay, so now for all elements from 5 till n minus 1, we can convert them into 1. Okay, now we have a 2, a 4, and the n. Okay, now in two moves we can convert the n into 1 in two moves. Okay, let's keep a track of the moves again. So we did one move here, then I think n minus 1 minus 4, I think, plus the one from earlier. So this is n minus 4, I think. We did n minus 4 moves till here. Here we have n minus 2 moves. Okay, and all that's left is a 2 and a 4. Okay, so that's it. We just have to convert the 4 into a 2, 4 into a 1. Okay, I think now we did n moves. Assert size of moves equals n, and now we can just print it. Did we use n moves? I think we used n minus 1 moves. Because here we used 7 moves, right? We saved 1, 2, 4, and the last one. So these were n minus 4. n minus 2 and n minus 2 and an n. Hmm. Should be n minus 1 move, right? How is this n? Like if we had more elements, we would have used 6 moves here. So how is this not n plus 6? Let's try to run and see. We already have the assertions, right? So let's try it on 10 test cases. Okay. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Everything worked. That means all our assertions passed, right? And it worked for all the small values because of this. And it's working for bigger values, right? Like if we have two test cases, two really big test cases. Okay. Okay. Yeah, so I think it's working. Okay, so we can submit it. I'm still a little confused how this is taking n moves. If this took n plus 5, aren't we saving 6 moves? Okay. One of the moves was the element itself. Okay, it's fine. Wrong answer. Test 2. Okay. Okay. Maybe our moves are wrong. Hmm. So these look all right to me. Like these are n plus 5 moves, and n plus 5 is definitely not more than n plus 5. Okay. Hmm. So for 3 it is definitely correct, for 4 it is correct, for 5 it seems correct, for 6 okay, yeah, this is fine. Okay, this is wrong. Why do I have 5 7 twice? Oh, this is IN. Okay, sorry. Okay, so just a typing mistake kind of thing. Okay, so I'm gonna explain how my solution for the problem D works. Okay, so yeah, so if we had less than 8 elements, like you can come up with a lot of different solutions for n less than 8. So I'm only talking about n greater than 8. Okay, so we have elements like uh, we have elements like 1, 2, 3, 4 till 8, and then a lot of elements till n. Okay, so we can use n minus 5 moves. Okay, and in each move like we will just save these 5 elements. Okay, and other than that we'll convert everything into a 1, and to convert any element into a 1 we just have to divide it from n. Okay, so we can use a move like xn, and that will convert x into a 1. Okay, so this will cost us n minus 5 moves, and then our array will look something like 1 2 1 4 1 1 1 1 1 8, then 1 1 1 1 1 1 1 n. Okay, and we have 10 more moves. Okay, so we have to convert this into uh, like we just have to leave ones and twos, and more precisely only 1 2 and everything should be 1 in 10 moves. Okay, so we have 10 more moves. Now if we do 6 moves of dividing this 8 to this n, like we do n by 8 6 times. Okay, so this will convert it into a 1, and I know this because 8 to power 6 is greater than 2 into 10 to power 5, which is the constant on n. Okay, so that's why I can do it within 6 moves. Then I have 4 moves. Okay, I have 4 moves remaining, and my array looks like 1 2 1 4, and everything else is a 1, and we have a 8. Okay, so we have 4 moves to convert this into everything 1. So we can use this 4 and divide it from 8 2 times. Okay, so if we do this 2 times, then we'll have 2 moves, and our array is 1 2 1 4 1 1 1 1 1 1 1, and then just use these 2 moves to convert this 4 into a 1, and that's how we can solve this problem.